Hello there, gang, and welcome back to the New Blocks, episode 11. And today we are talking about smart contracts. Kevin, I'm excited to be back again. Always excited to be talking blockchain with you, buddy. And today we're talking about Ethereum specifically. Oh, and that really tickles my jimmies.
Oh my God, me too. I'll tell you what, smart contracts are one of the funnest topics that you could ever imagine talking about. But it's a little bit dense, this episode we're going to try to keep it a little light. We've mentioned this idea of a smart contract in the Ethereum episode, and smart contracts are not specific to Ethereum, but just kind of based on the way that this technology has evolved. A lot of what's interesting is kind of happening on Ethereum.
It's one of these things that's cool because it enables us to talk about some real world use cases, both some stuff that's a little bit theoretical and kind of in development, and also some things that are a little more tangible and actually happening right now. You know, smart contracts are this glue that really enable a lot of human creativity, and there's probably going to be a lot more cool things we'll be able to do with smart contracts in the future as the innovations continue. So this is another one of these kind of layered aspects of Ethereum blockchain I think is pretty darn cool.
Yeah, and it's a really core building block, a new block, you might even say, that is important to understanding where this technology is leading. So at a high level, a smart contract is really just a computer program or a script that automatically executes code on a blockchain to facilitate the flow of information and or money given some sort of set of rules. A lot of times you'll hear this analogy of a smart contract as similar to a vending machine. So, you know, you think of a vending machine, you put your money in the slot, you press a button, you tell it what you want. It responds by doing that thing, giving you that piece of that goods, and updating, you know, its inventory. So now it knows there's one less soda in there. And there's no person there. No one's taking the money and handing you your soda. It just happens. There's a machine there, a mechanism for it to just do it automatically. And that's why, you know, smart contracts at a very fundamental level are kind of similar to vending machines in that way.
All right, so it's sort of just like a digital agreement that exists in cyberspace on the blockchain. So it's transparent, it's visible. Both sides can see the contents of the contract before agreeing to it by sending some sort of cryptocurrency to it. And it serves as this kind of automated middleman, so to speak, that allows us to interact in a pretty trustless nature, right? You and I might not trust each other that much, but we trust this middleman that is the smart contract because we can both see exactly what the middleman is capable of.
Yeah, and the name smart contract does come from this sort of legal world contract, but it can be a little bit of a misnomer in some ways. It's not really written in the English that we think of. It's written in a programming language, and so it's a contract for a computer to execute. But at a high level, it does sort of map to the conceptual idea of a contract where, you know, you have people that agree upon some rules, and they just want those rules to be the way that they work, whether it's a business or some partnership, whatever. You could think of it as sort of like the next version of that idea, in more of an automated way that you're not relying on the other person. You don't have to trust the other person. It's just executed automatically. And this idea makes smart contracts pretty game changing in a literal game theoretical sense.
Right.
You've talked a little bit before about this idea of the prisoner's dilemma. Let's talk about that again.
Yeah, for sure. It's pretty cool because a lot of cryptocurrency and blockchain stuff is based on incentives, right? That's like a huge part of these consensus and governance mechanisms that we keep talking about. And that's really what Prisoner's Dilemma is all about. And for those of you listening, we do have a little visual for this one that we're going to take a look at here. And the Prisoner's Dilemma is this thought experiment where you have two people that are working together to commit a crime. And while they're committing the crime, they get busted. The cops arrest them. They take them into the police police station. They put them in separate rooms and they question them, and they lay out on the table, hey, if you rat out the other person, we'll let you go. You get 0 years, and your accomplice here that you've ratted out gets 20 years. Now, individually, they each have a huge incentive to just rat out the other guy and walk away. However, if they both do that and they confess and point the finger at the other person, then they both end up going to jail for a period of 5 years, let's say. However, if they both choose to remain silent and stonewall the police, they would only go to jail for a year because they don't have enough evidence or a confession to put them away for like a grand larceny crime. So this represents kind of a four-way grid of potential outcomes where the one that ends up being the most efficient within the system, where the two of them only go to jail for 2 total years, that is in contrast to are their individual incentives, but ends up being the best outcome for both of them if they can somehow work together in a system where they're completely isolated and have no way to really collude or reasonably work together. So it's sort of a fascinating piece of game theory that kind of displays the paradox of this decision-making power.
Yeah, because if each person is working in their own self-interest, we end up with this pretty bad scenario where both people get thrown in jail. But if both of them can trust the other person, or at least trust that the other person won't talk, then they themselves would remain silent as well. And they end up in the scenario where they both have some small, maybe 1 year sentence. But in terms of the collective years spent in jail, it's kind of what's best for the group in this situation.
Right.
And so if you introduce smart contracts to the prisoner's dilemma, let's say prior to committing the crime, both people put $100,000 and lock it away in a smart contract. And they write the rules of the contract such that if both parties remain silent, then they can both receive back their money. But if either of them breaks this contract and confesses and rats the other person out, they lose their $100,000, and that other person gets all of the money. Mm-hmm. So it introduces this additional mechanism to incentivize the prisoners in the prisoner's dilemma to both remain silent. And it really just aligns the incentives of the individuals with that of the group. And so at a high level, smart contracts are this new building block that allow us to create more incentive-aligned creation of better open public goods. And public goods are probably this concept that we're all kind of familiar with, but it's based in economics, and it's probably been a while since you've heard more of a formal definition to that. But
okay, so real quick before we go too deep on the public goods, that was like a dense string of sentences you got there, my friend. So I guess how exactly does all of this connect together with the prisoner's dilemma in terms of smart contracts? I guess can we clarify that maybe in layman's terms real quick?
Yeah, it's essentially if you are going to go, if you have some existing set of incentives. So in the case of the prisoner's dilemma, this is a single game theoretical scenario, but there are many different ones. Prisoner's dilemma is sort of the common one.
Right.
You have some existing set of incentives where in many cases it sort of pits individuals against each other. And if they
could just find a way to work together, then it would be better for both of them.
Exactly.
Right. So the smart contracts create an incentive to actually make that happen.
Exactly. And so it shifts the trust that the people have to put from the other person into just the smart contract, into math, into
in math we trust.
Computer science.
See.
Exactly.
Okay. So gotcha. So the removal of the middleman is a big part of what aligns the incentives of two people to be able to just trust each other to do a transaction.
Yeah, there's no longer a need to trust the other person, because as long as they are a rational actor, a rational human being, they do not want to lose their $100,000 or
Right.
whatever the amount is, right?
Yeah.
They will
Okay.
do what is in their best interest. And uh, like you mentioned, a big part of crypto really is about this idea of incentives. It's this combination of trust in mathematics and trust in sort of like the rational human,
Hmm.
that kind of allows us to have these new building blocks.
Yeah, it reminds me of that 51 attack concept we talked about, I guess, 1 or 2 episodes ago, where theoretically somebody could pay to 51 attack a big cryptocurrency, but it's so expensive, really no rational actor would do it because there's so many incentives against doing that action, right? So it
Yeah.
that's just an example of how
Yeah,
incentives
you
sort of add security layers to the network to some degree.
yeah, if you end up burning more money than the thc that it is you're trying to achieve, it's there's not a lot of incentive there. And
Yeah,
similarly,
yeah.
if you're going to lose 100 grand just to go confess and rat out your friend, there's not a lot of incentive there.
Yeah.
So that brings us back to this idea that smart contracts allow us to create uh, better, more open public goods. And so I love going into my definitions and stuff. I know they're not a lot of fun. In economics, public goods have two. I'm sorry, just goods in general. So you think of your watch, your shirt,
Yeah,
your
just
car,
items, things that we buy.
items.
Yeah.
Yep. There's sort of two important attributes to a good. There
Okay.
is whether or not it is excludable. You can think of this as a good where ownership is limited to a paying customer, or ownership excludes other people. And the other important
It's
attribute
like kind
of
of
a
like a
good,
finite supply. Like there's only so many Mercedes out there of this year, of this color, of this model. If I buy
yes,
one, there's one less for you to buy in theory.
yes,
Right? That's
exactly.
okay.
And it the other attribute is this idea of whether it's rivalrous. So a good where consumption affects the total supply, ownership rivals other people. So maybe your example of like there's only so many Mercedes out there, maybe that goes more into rivalrous.
Ah, okay.
But like these two ideas are very, very close. But if we go through some examples, I think it'll
Okay.
start to make more sense. So
Gotcha.
a private good is sort of what we're used to when we talk about goods. It's something that is both excludable and rivalrous.
Okay.
So
So that's the
food,
car.
yep, cars, parking spaces. Like there's a limited supply, and you are sort of incentivized to like take what you can get because others will take it from you if you don't. And then there's the what are called club goods, which are excludable and non-rivalrous. You could think of this as like paying customers getting access to something. You think of like amusement parks, video streaming platforms. It's like once customers have paid, there's not a limited number of plays for a given movie on Netflix. Like anyone can just go watch
Uh,
what they want on Netflix.
okay.
Next, we have this idea of rivalrous, non-excludable goods. So you can think of this as what are called common pool resources. So you have like fish in the ocean, timber, coal, just mostly natural resources, things that like
Okay.
we as a species need to kind of like preserve, but every individual is sort of like incentivized to like go take their cut of this.
Okay.
And finally, public goods are both non-rivalrous and non-excludable. So you think of things like the air that we breathe, sunlight, education, and public infrastructure, the things that like we as a society may pay for, but like once we pay for it, it's open to anyone.
It's just kind of
Um,
there. Okay.
yeah. So when I flush the toilet, it doesn't prevent you from flushing the toilet. Stuff like that.
Okay.
So the
All
reason
right.
why I've just explained all of that is this idea of Ethereum, right? Ethereum is a public good. Um, Ethereum is both non-rivalrous and non-excludable. So it is just a thing that now exists that anyone can interact with. and my interacting with it doesn't stop you from interacting with it.
Okay.
And an extension off of that is that smart contracts allow Ethereum to exist as a platform for building other open public goods. So it is a platform that is in itself a public good that
Okay.
allows for the creation of open
Okay.
public goods.
So this actually kind of makes some sense though, right? So again, very dense stuff here, but like ICOs, right? We go back to 2018. I always talk about these ICOs because I remember that time so well. It's like one of the wildest crypto booms to ever be a part of and kind of witness firsthand. I'll never forget just the chaos and turmoil that ensued at peak ICO times. But that was made possible by this idea of a platform that creates platforms. That's a little bit meta, but Ethereum is this public database. So on that public database, you can build applications that use that transparent nature as kind of a back end for ownership of digital goods. But these different apps, or dApps, I guess I should say, do different things. And some of them are platforms that allow people to create stuff or build things or launch further tokens. Like there's even an example of an esports token that it's a platform built on Ethereum that then esports players and personalities can launch their own platforms on. So it's a third layer of platforms launching
all the way down. Yep.
Which, and maybe that's a little too much, but this is making some sense. You know, I see what we're getting at here. That's potentially quite powerful. Now that we've just seen some of the ICOs that have turned into something good.
Yeah, and I think like creating your own cryptocurrencies, that's a single application that smart contracts allow for you to do very easily, right? It took us from having to bootstrap your own blockchain, get miners, incentivize them to run hardware, software. Now you can just release a smart contract that says like, oh, here's a new cryptocurrency. It's called XYZ. It's got this much market cap, total supply, rather. And it makes it pretty easy. But I mean, in addition, like this idea of just this uncorruptible third party that can hold money until some date or event occurs, like our example with the prisoner's dilemma. It's really just like this escrow that exists on a computer and not through a person.
So, and like, again, to tie this to the real world, we have, a platform I just used, right? I just had some pictures taken. I used Upwork to connect with a contractor. I put money into Upwork in escrow before that person gets paid. But then when I check, hey, they delivered on the work that they said they did, that money gets paid to them. But putting it in escrow, that gives the contractor confidence that I actually have the money because Upwork is holding it as a third party in the middle. But what are the downsides? Well, Upwork takes a percentage of that, a pretty chunky one, I think closer to double digits than it should be. And also, if something happens to Upwork, right, if they were to file bankruptcy or whatever else, they own that whole platform. They could, for whatever reason, turn off our service if they wanted to. What happens to that money that's in escrow? Well, it's in their bank account while we figure that out, right? So this is a decentralized alternative to that allows you, as we've gone back to trust math instead of a private company as a middleman. Yeah. So it's a nice alternative. Paying 0.5% to a contract is way better than 5% to a private company.
Yeah, and just this whole idea of creating decentralized alternative to existing applications is kind of a powerful one once you understand the value proposition of decentralization. You think of like a social media platform that where the moderation privileges and like the data ownership is decentralized. Right now, I mean, you look at Facebook and Twitter, and just last Thursday, the India government asked Twitter to block a bunch of tweets that criticize the way that they handled the pandemic. And Twitter did it because if they didn't, India really has the ability to just shut off Twitter in the entire country. So again, it's this idea of incentives. Like Twitter is incentivized to do what's best for their shareholders.
That's maximize users.
Maximize users. And that comes at the cost of dealing with governments just
Yeah.
shutting down anyone that speaks against them. And so you can imagine in the future, and Jack Dorsey has already talked about how he wants to decentralize Twitter in the future, but a decentralized alternative to Twitter where, the platform, there is no one that can shut off
Yeah.
some given tweets. If anyone wants to turn off something, like when you remove the button entirely, I've heard a good, it changes a lot. I've heard a good little quip here of Google's old slogan was "Do no evil" or "Don't be evil," right? There was this blockchain company that took that idea and just said "Can't be evil." It's the difference between saying that you're gonna not delete the buy button for your GameStop stock, and just like physically not being capable of it.
Yeah.
And that's
Right.
really the building block that smart contracts allow for.
Yeah, it's one of these weird things that I think sometimes people have trouble visualizing, where it's like, well, I don't have a reason to not trust them.
Yeah.
Why would Robinhood purposefully remove the buy button? And it's like, well, you can trust people up until the point that you can't trust them anymore, and that's
Yeah.
that old quip, "Power corrupts." And I think there's a lot of truth to that, despite it being rather cliche. And
Absolute
having a
power
system.
corrupts. Absolutely.
Yeah, and if you have a platform that truly doesn't allow for that power to be corrupted in that way, it's not a choice to not use it. You just simply can't use it. That's powerful.
Yeah.
Like, think about game mechanics, right? Games like poker and whatnot, where there's a gambling element, being able to transparently verify or even like loot boxes, being able to know those exact numbers, know that that's not a misprint or marketing bullshit or anything else, but that is the code, right? Live and die by the code. You're looking at it, you can see what the numbers are, and you can prove that you're playing a fair poker game. All those conspiracy theorists that are convinced that there's some algorithm out there for whatever platform they're on, that goes away because you can literally see the numbers.
Yeah.
That's all. I mean, we could argue all day whether or not gambling's a good or a bad thing or neutral, but if it's going to exist, I'd prefer for it to be more transparently fair, remove some of the bad actors from the equation, right? Isn't that just a step in the right direction?
Yeah. You look at lotteries, for instance, right? You have this centralized company that is taking a bunch of money from everyone and giving the vast majority of it to a single winner, but they take a big cut in the process. Ethereum has what is called a lossless lottery called Pool Together, that takes this concept. You remove the third party, no one's there to take a cut. Everyone just pools their money together in a smart contract. That smart contract goes and invests that money into DeFi. And at the end of the week, instead of everyone losing their money and someone getting all of it and this centralized third party taking a cut, the winner just gets the interest that was earned over the course of that week, which is a surprising amount for Pull Together. But it just creates this new way to build things where when you remove third parties, it changes a lot. Just financial tools in general. It's sort of all of DeFi, like lending, borrowing, and exchanging, where no one is capable of running off with the money, and you don't
Right.
have these big cataclysmic events, or even just smaller banks getting away with fraud and all the shit that banks do.
Yeah. No, totally.
Yeah.
The flow of money is a big deal, and I think that's really one of the big broad stroke aspects of this. When we brought it up, I think in our legacy kind of financial system conversation, but money moves really slow, and having improved ways to automate the movement of money is pretty fascinating. I mean, there's a real future world where getting paid hourly means every hour money goes into your account, or based on some sort of task performance. If you're a barista, for every cappuccino that you make and click the button on the register, you get paid your commission right there in your account on the spot. You get your tips right there. It doesn't get counted at the end of the day. That kind of stuff is also made possible by smart contracts, and that's a game changer, man.
Yeah, and I've heard one good description that I like. that is money grows to sort of encompass the containers that we put it in. So when we first just had paper money, we had $1 bills, $5 bills, $20 bills, whatever denominations. And so you see things like the dollar store pop up where it's easy to give a dollar for something. So the ecosystem sort of evolves around that idea. The reason why we have 2-week pay periods is that it is expensive to move money. It's expensive to pay people. You have an entire payroll team that it's entirely their job just to go through the flow, make sure that all the connection between all the bank accounts work. If you can just automate the payroll, automate the flow of money, you get to do crazy new things. Not even just the idea of automating like the payroll department, but just create new ways for humans to organize, new governance structures, and a new design for companies. Next episode, we're going to talk about a really interesting topic that goes more into this, but it really creates this way, this brand new way for humans to work together. And yeah, it's just a new building block that kind of opens up a lot of doors.
Yeah, voting is a key part of these governance structures, and token issuance is actually a really good way, not only just a representation of value, but a way to translate verifiable value and ownership into voting rights and voting shares. And I don't necessarily mean for like the presidential election. I mean within an organization like your place of work. You could create layers of management that have different voting rights, and it could get pretty cool and complex, and we're just looking at the tip of the iceberg at this point. But this is the groundwork to start opening up some of those doors.
Yeah, exactly. I think of smart contracts as this way for us to establish rules without rulers. This idea of still continuing to have a way to incentivize people to work together, but not necessarily needing this authoritarian style like governance process. We can work together in groups in ways that we don't need someone to hold our hand and to take a huge slice of the pie, or to just go more of the governance perspective of just like dictatorships, right? Like we don't necessarily. I think it's the shift of humans trusting other humans, a shift from trusting other humans to trusting mathematics and cryptography and just incentives.
It's so anti-authoritarian. It's like one step closer to the Star Trek utopia, man. Fucking love it.
God.
That anarcho-technological paradise I always dreamed of as an angsty teenager might still come true, Kevin. And it's all because of smart contracts on Ethereum. Oh my gosh.
My Star Trek comics behind me. I'm in it. I'm in it to win it, my friend. Let's get to the lightning round.
Yeah, let's do it. What do we got?
So everything that we just talked about sounds great. Smart contracts sound amazing. Let's just put everything on the blockchain right this minute. What's stopping me?
Yeah, so obviously fees, big issue. You hear a lot about gas prices. They've been high. Things have actually been a little bit different this week. Looks like we're starting to see some of these scaling solutions come into effect. But blockchains are still pretty inefficient from a pure data movement perspective. And you're still forced to be really focused on minimizing the amount of data and processing power that you're using on the blockchain. And that means if you have a large organization that the smart contract model is probably not going to be a super efficient move for you yet. But again, we're talking about groundwork here, all right? We're digging the foundation. We're pouring some concrete. We haven't started building the second stories yet. Well, okay, we kind of have started building the second stories. But you see what I'm getting at with this analogy, right? We're still really early on with this stuff. So we're not quite ready for mass adoptions with these big organizations that have hundreds or thousands of employees and varying complexity of financial contracts, right? This is much more applicable for like pretty straightforward kind of like hourly work or really repetitive tasks that are easy to log and kind of mark down that way. But we're working on it, so we'll get there, Kevin. Unfortunately, we've still got some bandwidth limitations. I think one of the analogies that you've used in the past, we're still on dial-up, man. We're on that 56K. My snip.net is still ringing in, and I'm waiting for web pages to load. But look at us now. All right, we got gigabit.
Yeah.
I'm streaming in 1080p, 60 FPS. We're gonna get to 1080p for blockchain in the very near future. We're just, you know, we're like 480p right now, maybe 360, something like that.
Yeah, it's important to remember blockchains are the least efficient database that exists in human history. And we are feeling every side of that. But what that means is only the most economically dense use cases can survive right now. And what I mean by economically dense, I mean that the value of a single transaction for the user needs to be higher than the cost of the transaction fees to do it, right? If you find, like this idea of economic density is trying to prioritize the most important little bits of information.
Right. No fat.
Yeah. Yeah.
Right.
So you talk about money is the first application. Money is important. We need the ability to send money around. And very simple applications, very simple usage. And so that's sort of what we're seeing first. And as we build out these scaling solutions, these layer 2 technologies, we'll start to see new ones. We'll start to, the bandwidth will open up, and we'll start to have more interesting use cases.
Yeah, absolutely. So what happens when a smart contract gets hacked? What do we do there?
Yeah. So short answer here is people lose money, right? There's smart contract insurance that exists in DeFi. There's a couple interesting projects right now. There's Cover and Nexus Mutual are just a few. But for the most part, there's a lot of smart contract hacks that have happened in the last few years, and usually a lot of money gets lost in them. So it is worth saying and reiterating 100,000 times that these are very early days, and that you should only put in what you are comfortable losing, because we are talking about, as a software engineer myself, I don't trust the code that I write for very much whatsoever. And the idea of like storing billions of dollars on a few lines of code is new, and it is scary. And but over time, we now as a species have this new tool set that we can where we are all incentivized to improve that code and build tools at a global scale where, in the traditional financial system, you're kind of your hope for catching bad actors or even just bugs in your code comes down to, the couple programmers that existed on a given project, or the single auditor that came in to audit some piece of financial software. We're now moving to this place where anyone that knows how to program has the ability to go look at these, and it's getting easier and easier for people to learn how to program these smart contracts. And so this wasn't the short answer. I said it was a short answer, but the other part of this here is this idea of, we've said it a few times, code is law, right? It's this, we can move to this place where whatever the code says is what happens. But what gets kind of interesting here, and not something we have a lot of time to talk about this episode, but is this idea of kind of the social layer that sits below the code, the social consensus. So typically, we don't need to think much about this with a blockchain. The only time that social consensus changes the flow of a blockchain is through a fork. But if you think about, we've seen already in a few instances with these smart contract hacks, these financial protocols have cryptocurrencies, they have tokens in themselves that have value. They have people that can vote on proposals, and what has occurred recently was an instance where a financial protocol was hacked, and millions of dollars were lost for users. Well, the voters, the users of that protocol said, "Hey, like this is clearly not going to be great for us. What if we were to print new tokens worth the value of the amount that was hacked, and sort of distribute it evenly back to the people that were affected?" And like there gets into some interesting conversations about immutability that we'll go into. But
yeah, that's a whole episode right there, bud.
It really is. But yeah, that's just there's kind of a mushy area with this code is law, and that's really this idea of social
code is
consensus.
law until we all vote to change the law, man. Then
Exactly.
What is the law? It's just
Yeah.
code. Oh, in circles we go. Okay, cool. Man, I love being a
Yeah.
programmer. Nice.
Yeah, it's yeah. you said it perfectly. So, all right, next question. I saw this cool NFT that cost $20, but when I went to go buy it, the transaction fee was going to cost me $50. Why would anyone pay for that? And what can you tell me to help me around this scenario? Because I still want that NFT.
Yeah, no, I've heard of this one a few times, and like some of the allure of some of these NFTs is that they're really cheap now. They kind of feel like a penny stock, and it feels worth it to gamble with a $20 bill that you would throw away on a meal or something anyway. But yeah, that's part of the issues with this expensive database that we keep talking about. Gas fees have been pretty high, at least here in April of 2021. But now that they've been down a little bit, things start to feel better. So there is a degree of patience. I know with NFTs and collectors, that isn't really a great answer. Unfortunately, there isn't an in-the-moment solution to high gas fees. But what you can do is be patient within time of day, because it does seem to fluctuate around China, Europe, North America. These are kind of the big major time zones that, yes, it does cover a lot of the globe, but like Sundays, surprisingly weekends, and late night in kind of USA times when a lot of the world is asleep is really a time where you can see noticeable dips in the average gas fees on the network. There's a really great website called gasnow.org, and it shows this heat map over the course of an entire week, broken down into hours of how it fluctuates, and you can get a really good feel of these times where gas fees are really low, and that's when you want to try to do stuff on the network, move your ETH around, whatever it is you got to do. So yeah, we're going to keep talking about scaling solutions. I think we're going to do a whole episode on that. But they're in the works. There are absolutely solutions to some of the issues we've hit at this point in terms of demand on the network being high, because that's fundamentally what causes gas fees to go up. There's a set amount of blocks, right? There's a fixed supply, and if something really exciting is happening, or there's a lot of news about NFTs, or everybody's trying to buy this thing, or crypto kitties are getting frisky and breeding like crazy, the network gets bogged down, and it's a bid system. So demand outweighs supply, gas fees go up, and they don't go down until that demand goes down. So, yeah, good luck there, cool. Kev. A little patience, and you'll get it. You'll get there, buddy.
A little patience goes a long way.
Okay, so where can I learn how to write smart contracts? How hard are we talking here when it comes to putting something together? What if I want to set up an escrow for my business or some transaction I got going on?
Yeah, so it requires a bit of programming, but it's not hard from the perspective of it's the same language that powers all websites. So it's a flavor of JavaScript that, in the case of Ethereum, is called Solidity, and so it's sort of like you can think of it as the computer language that you need to use to write the logic of the smart contracts. And like a lot of smart contracts are much simpler than you would anticipate. There are tools that kind of make this pretty easy now. There's standards for money. There's ERC20 standard that gives you sort of the building blocks for a basic money, and you can just when you create a new ERC20 token, you can use an existing smart contract, write in the name of the token,
template.
Yeah, well, templates, exactly. You have ERC 721 for NFTs. You don't
Mm.
necessarily, if you're just talking about like creating a new money or a new NFT, you don't even need to write the smart contract underneath it. But if you want to get more into this world of being able to program on this new trust machine, I would consider looking at there's an online course site called Solidity for Zombies that's worth checking out. Additionally, if you start going down that path, I would recommend Truffle Suite. It's just a developer toolkit that kind of gives you some really nice, useful tools that you can start learning to write smart contracts. But yeah, I mean, I encourage anyone that's finding this stuff interesting to at least look at it, because I mean, this is still incredibly early days, and smart contracts engineers are in very, 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 very high demand right now. There is a lot of interesting stuff that people are building, and there is just not enough warm bodies to fill the seats and to start typing on these laptops and produce some smart contracts. So
there you go. Hope remains. But wow, super exciting stuff, Kevin. Thank you so much, per usual. Appreciate your expertise. And next week, excited to talk about some DAOs. You're probably wondering what a DAO is right now, and you're going to continue to wonder until you come back next week for another edition of the New Blocks. Folks,
Google it.
Yeah, remember, hit us on YouTube, find us on Spotify, iTunes as well. We appreciate your likes, your love, your comments, any kind of feedback. If you're just along in the journey, we'd love to hear from you, and just tell us where you're at with crypto, what you're doing. We check the comments. We'd love to engage with you. So thank you for listening. Remember, crypto is risky as well. Don't put in more than you're willing to lose. None of this is financial advice, but we appreciate you listening to us nonetheless. We'll see you next time.
Have a good one.